Hi, everyone. Hope you're having a good Monday so far. If you recall where we left off, we did a friction lab on Friday with your shoe, and I wanted to now do an example problem with friction, applying what we learned, particularly that there can be a force of friction, and it depends upon the coefficient of friction, which is the grippiness, if you recall, and then also the normal force. So this will sort of be the pinnacle of the unit, which, if it is, there's going to be a few pieces of information that we need to piece together. All right, so kind of a detail problem. Anyway, I'll set this up for you guys. So I have a problem here. A person applies a 600 Newton force on a 50 kilogram crate, and the force is applied to the right as shown in the picture. Question is, what's the acceleration of the crate if the coefficient of friction between the crate and the table is 0.3? All right, FBD we always want to draw first. Some of this you guys will fly right through, but we know that, of course, if it has a mass and it's on Earth, it's going to have a weight, which we call gravitational force. And if it's on the ground, it's going to have then a normal force from the ground that'll be pointing up. I do want to make sure I get the size of these right. You can see I drew that a little small, so let's make it bigger. It's not going to move vertically, so the gravitational force and the normal force from the ground should balance out. All right, we will actually apply that idea, so I do want to start to set up big ideas like this, where in the y component, things should balance out, and that's Newton's first law. All right, so the weight and the normal force added up need to be 0. So this is old news, but it will actually be useful for us, so you can go ahead and do that. The new component is definitely with friction, so if I try to pull something to the right with an applied force, if there is friction, friction always opposes motion, so it would be to the left. Now, I don't know the size of the friction. I know the applied force is 600 newtons, so you could actually write that in there if you wanted, Fa equals 600 newtons. But all I actually know is the coefficient of friction. So you have to remember this is not the force of friction. A major way to know it's not, look at it. There's no units. So it is basically the grippiness between the materials, but that lets me know friction is present. So since there is friction, it will oppose the motion like we said and be to the left. And if you're getting this to move, because I'm asking you what's the acceleration, if you're getting it to move, then that means it must have started from rest and now started to move to the right because of this person. So it's going to accelerate to the right, which means the unbalanced needs to be to the right as well. If you think about it then, if you have an unbalanced force, here comes the biggest idea of the unit, Newton's second law. I want to make sure to kind of emphasize this with a different color. The biggest idea in this unit is that if you have an unbalanced set of forces, in this case the applied force and the frictional in the x component, you will then get an acceleration to occur. So, with that being said, and setting up Newton's second law, I now have an equation to solve for the acceleration. So from here, it's just, hey, we got to plug in what we know and solve it out. So I do actually know that the person applies a rightward force of 600 newtons. So that can go in for force applied. But here is the new twist. I don't know the force of friction. So it's good to set up big ideas, but you might have to pause. I don't know the force of friction, so I have to stop. All right, and this is where we've just got to think about it. In the lab, we learned a new equation for the force of friction. All right, so what I'm actually going to do to try to order this the best I can, I'm actually going to take Newton's second law, and even though it is a big idea, I'm going to save that for the end. All right. So we actually learned that the equation for force of friction is, I'm going to try to prep this again with kind of the ordering, force of friction is dependent upon the coefficient, which is again just the material's grippiness, and the normal force. So we have this new equation, and if I can solve for the force of friction with this equation, I can then plug it in to Newton's second law. But to do this, I need to know two things. I need to know the coefficient, which is the grippiness. Good news, I do know that. And I need to know the normal force, which I don't actually know. All right, so let's go ahead and do this, though. I know the coefficient is 0.3. So the force of friction is equal to 0.3, and then I've got to figure out the normal force somehow. All right. Well, again, keeping in mind I like to set up big ideas without getting too quick into numbers. We actually have an equation over here that has normal force in it. So I could use this equation to solve for the normal force, but I've got to first figure out the weight, the gravitational force. All right, so let me try to kind of organize our work real quick here. Let's move this over here, because if I get the normal force here, I can then plug it into this to get the force of friction. And then if I get the force of friction, I can plug it in here. So it's kind of this puzzle we've been talking about. But I've got to figure out the gravitational force. I'm going to make one adjustment real quick at this, kind of shrink it down a little bit. Oop, not too small. Put it maybe right about there. Okay. So gravitational force. How do we get this? Well, this is day one stuff. This is easy. I know any gravitational force is equal to the object's mass times an acceleration, but not any acceleration, Earth's gravitational acceleration, because this is a gravitational force. So if I look up here, I see the mass is 50 kilograms. I can then come down here, and the gravitational force is 50 kilograms times the acceleration due to gravity on Earth. I hope you have this memorized by now, is negative 9.8 meters per second squared. All right, so let's start doing some calculations. If I solve this out, I get the weight to be, and it should be negative, that makes sense, 490 newtons. All right, so based on the bigger picture, if you kind of look at my puzzle I've created with the laws and the friction equation, I can now bring this up here to solve for the normal force. So if the gravitational force is negative 490 newtons, since this crate is balanced vertically, not moving vertically, that is, the normal force needs to just be the opposite of that. Force normal equals positive 490. All right. Again, now that I know the normal force, I can just bring it right here, organize that kind of nice. But now, if I plug it in right here, let me get a calculator for this. I've got to do 0.3 times 490 equals 147. And the units would still be newtons because it's still a force. All right, so let's just back up, kind of see where we're at real quick. We basically, let's highlight in a different color. We got the gravitational force, which then helped us get the normal force, which that then helped us get the force of friction. And now we should be able to finish the problem with Newton's second law. All right, one catch though, and this is sometimes us just going too fast. You'll notice the force of friction equation has absolute values. It doesn't tell you the direction of force of friction, it just tells you how much friction is present. So what you always have to do is look back at your FBD. If you look at my FBD, friction is to the left. So I need to know that when I plug in the friction into this equation, I need to know that it's going against the person's pull. Which makes sense. Friction never helps you pull something across the ground. It always resists. So I have to just double check my direction from the FBD. All right, from here it should be pretty easy. So 600 minus 147 should be, off the top of my head, 453 newtons. Yell at me afterwards if I'm wrong, since this is a video, but I think that looks good. And of course, final step is to divide by the divide by the mass, which it looks like we're going to get about 9 point. I just want to hit it right on the head. 453 divided by 50 equals 9.06. All right, I could round that up a little bit. Let's go. 9.1 keep in mind units for acceleration. A Newton divided by a kilogram is a meter per second squared because it is an acceleration. All right, so you can see we used 4 equations in this. A weight equation, we still actually applied Newton's first law, which helped us with the new force of friction equation, and ultimately let us finish the biggest idea of the unit, Newton's second law right here. So try to always think of the big ideas before you get too fixated on numbers. Drawing an FBD and understanding how the motion is or if it's changing will help you out tremendously, okay? All right, of course, have this in your notes. I want you guys to now try the next problem for Webassign, which there's only one. It's on friction. Okay, if you struggle a little bit, I completely understand, but you want to get this practice in because we're nearing the end of the unit and we don't want to wait last minute, okay? All right, guys, hope you're having a great day. Good luck.